Telecompany Douglas Productions and Svetlana Productions. Movie Part 3. Oscilloscope Experiment. Sponsor of program Douglas Konzin and Director of Stage Svetlana Konzin.
Okay. Alrighty, due to unpopular demands, I'm going to scope this transverter single-ended bit three-phase transformer core with the shorted B phase. And here we go. This is the output from this C phase, the secondary, into a load of a light bulb here. And what I'm moving right now is the current. And there's really no phase shift at all at this point. However, I'm going to plug in this parallel 20 UF cap in parallel to the load of the light. The light is so much brighter. Now I gotta get this kind of evenly spaced. Sorry, it doesn't all appear on the scope, but it's on my eyeballs. It looks good. I can get the phase shift. You can see the phase shift right here. Looks like 2 and 2. Looks like it's evenly. You want to have the zero line like right in the middle of the top peak and the bottom peaks. So this, I calculated, I took a photo of this and then blew up the photo, and this is the output phase shift. No cap. There's really no phase shift. This is about 2.5 spaces of a phase shift, and one cycle's 12 spaces, which you can call minor square divisions, but I'll call it spaces. And at 2.5 spaces and 360 degrees divided by 2.5, but whatever, this is 75-degree phase shift, which means a 0.25 power factor. This is on the output. And it's capacitive leaning, which is what to be expected. What I'm moving now is the capacitor, the current. So it's capacitive leaning. Now, let's go to the big baby. 42.5 UF cap. Now it's just light bulb's just explosive. And let's make this so we can have it balanced. The zero line right in between the peaks. And you can see the sine wave is different now. The current comes straight down and then it goes up at a slope, while the voltage is fairly curvy. So this is what the current looks like and the voltage looks like with the phase shift coming out of the third phase into the load with a cap across it. Now, output phase shift. I already calculated this with a photo blown up so I can count the spaces, and this is actually 90-degree phase shift. Isn't that interesting? Because it's 3 spaces of a phase shift between the current and the volts. And considering there's 12 spaces per 360-degree cycle, that's 30 degrees per space. So that's like 90-degree phase shift. Isn't that odd? So that is what's coming out with a big cap in parallel. Okay, let's take this cap off. Things are getting hot. Now, I'm going to look at the input. I'll tell you what the output, the input is. The one space, it's inductive with no cap, but it's only about a half a space. And if it's one space, it's 0.86 power factor. The 20 UF cap makes a 60-degree phase shift, and it's capacitive. And that gives a power factor of 0.5. And remember, this is the input I'm talking about. Now with the big cap, 42.5, again, it's 3 spaces, but it's capacitive. And remember, this is the input. The input's affected by the output. Putting caps on the output affects the input. So it's a capacitive 3 spaces in between the voltage, and that's a 90-degree phase shift again. Isn't that interesting? So hold on a sec and I'll hook up the input, what it looks like on the scope. I just gave you the what it all means. So hold on a sec.